All right, so we spent a lot of time talking about chemical bonds, what's the difference between an ionic bond and a covalent bond, and so now we're going to be looking at it in a little bit more detail. We're getting into the nomenclature, which is just the names of these different compounds and what information the names can tell us about compounds. So we'll start with the first section with covalent compounds, and in the next section we'll get into the ionic compounds. But for now, let's focus on covalent compounds. Now, here's the vocabulary that we'll be going over. You'll be more familiar with this after we finish this video. So, those vocabulary terms are covalent compound, a chemical formula, subscript, molecule, and nomenclature. And then, as a bonus on here, I have a clip that I want to show you. It's from Penn and Teller. These guys are two magicians. And in this video, I thought it would be fitting with what we're talking about here about the names of compounds. Because in this clip, they go around to an environmental rally and they convince a lot of people to sign a petition to ban water. And it's actually really funny because they don't lie to them. They don't say anything that's wrong. All they did to trick them was use the chemical name of water. And so it's really interesting to see. So that's why I wanted to share it with you. So let's take a moment and just briefly review over what a covalent compound is, because this section in that we're talking about, we're dealing only with covalent compounds. We're leaving the ionic compounds for a different day. So let's go ahead and review on that a little bit. The covalent compounds, remember, these are compounds that are made of two or more nonmetals. Remember, the nonmetals are those that are on the right side of the periodic table. They're in yellow in this graphic, and also hydrogen. So make sure you're familiar with hydrogen, carbon, nitrogen, oxygen, fluorine, phosphorus, sulfur, chlorine, bromine, and iodine. Those are the most common ones we'll be dealing with. So I could have also just said to leave out the noble gases, and then selenium and astatine. Really, we're not going to see those very much, but just be aware that they're still there. And then we also have this other item called the chemical formula. And so this is what we're so used to seeing for chemical compounds. It tells us exactly what elements are part of the compound and then how many atoms are bonded together. So let's start with one that's familiar to all of us. It's H2O. We're very familiar with what water is. We've been saying this since elementary school. So now, there's two important parts to a chemical formula. The first is the element symbols. So of course, here you have hydrogen and oxygen. We're pretty good at identifying those already. So what this is telling us is that this compound of H2O, it's made of both hydrogen and oxygen. Now, the next part that we need to know from this chemical formula is the subscript. This is the number that is written a little bit smaller and underneath the letters, right? That's what a subscript is. And in this case, it's telling us how many atoms of each element we have. So in this case, we have H, 2, and O. Now, we have a problem here where this 2 is right in between the hydrogen and the oxygen. So how do we know who gets them? How do we know who gets the two? So when we write them this way, the subscript always comes after each element. So in this case, because hydrogen is right before the two, we know that it's paired as H2 and not 2O. This will be H2, and it's telling us that we will have two hydrogen atoms. Two hydrogen atoms. And then for the oxygen, we need to see what number comes after it to see how many atoms of it we have. But now we have another problem where we have this oxygen and we don't have a number that comes after it. But this is just done to cut down on writing things that aren't really needed, because when we show that we have an element, we always assume that we have at least one. So whenever there's not a number specified in the subscript of an element, we just always assume that it's one. In this case, this O means that we have one oxygen. And this brings us to a new vocabulary term, which is called the molecule. It's important to understand what a molecule is and is not. So if I were to draw this cute little cartoon of a water molecule, this is actually telling us the same information as this chemical formula over here, where we have two hydrogen atoms and one oxygen atom that are bonded together. And it's important to understand that once they're bonded together, they act as a unit. They don't separate very easily. But we can also bring in more molecules that are very similar. It's still the same elements, bonded together in the same way. So here we have another water molecule, one more, and three more. And so what's important to understand here is that these four are all the same compound. They're made of exactly the same stuff in the same number of atoms, but they are four individual molecules. And they will all have the same properties, but we can count them out individually. They're individuals in this case. Use the word individual a lot. Now that we've reviewed a little bit on what covalent compounds are and what information we can draw from their chemical formulas, let's actually get into assigning names to these different compounds. So for covalent compounds, we used what is used the IUPAC nomenclature system. What IUPAC is just an international committee of scientists. They set the standards and the rules that all the other scientists around the world follow. So that's the same rules that we're using. Now let's talk about this word nomenclature because it's kind of a big word. It's kind of unusual. So in case you haven't heard it before, if you don't know what it means, just know that it's a system for assigning names to things. In our case, we'll be using the IUPAC nomenclature to determine what our chemical names are. And it's a very good system because it's very descriptive. It's telling us exactly what's going on in a molecule. So let's go ahead and take a look at that. Let's start with, again, our old reliable example of H2O, a water molecule. Now, if we wanted to give this the chemical name, we have to follow a few simple rules, and here's the first one. We need to know the names of the elements that are in the compound. All right? So it's pretty simple. At this point, we've gotten pretty good at identifying different elements. So in this case, again, we have H and we have O, and these are both hydrogen and oxygen. We know these are the two elements that are part of this molecule, so we'll be using these two names to base our full chemical name on. Second thing we need to know is the number of atoms in each element. Again, just looking at this chemical formula, we already know all of that. We know that we have two hydrogens and one oxygen atom. All right, so next, we need to use number prefixes. So now, what are these number prefixes? You're probably already familiar with these, especially if you've already gone through geometry or if you're taking that right now. If you know your shapes, you know at least 5 of these. And so these are the prefixes. If you remember from middle school English, a prefix is just a word that we use to modify the meaning of certain words. And in this case, we're talking about numbers. Each of these numbers, 1 through 10, will have a number, will have a prefix that tells us that same information. So in this case, mono means 1, di means 2, tri is 3, tetra is 4, and so those first 4 are kind of not very commonly used, but after 5 it gets a lot more common. Where 5 is penta, you might be familiar with a pentagon. It has 5 sides, right? Then hexa, think like a hexagon, 6 sides. It represents the number 6, and so on. We have hepta for 7, octa for 8, nona for 9, and deca is 10. So just keep these in mind. We'll be using these a lot as we go through our covalent compound names. All right, so now we know our number prefixes. We'll be using those along with our element names. So in this case, we have 2 hydrogen. In this case, we'll be change out that 2 for the prefix of it, and we get dihydrogen. It's not 2 hydrogen, now it's dihydrogen that we're using for our name. And then do the same with oxygen. We know that 1 is mono, so we'll be saying that this is monooxygen. All right, so we have these two uh, parts of our name. We have dihydrogen and monooxygen. All we have to do is just put them together into a 2-word name for a compound. So we have dihydrogen monooxygen, or you could also read that as monoxygen. It looks kind of odd, and so this actually brings us to the next rule with 3. Just to simplify this, both on the pronunciation and the spelling, the writing of it, we're going to omit the extra vowels. So right here in this section, we have 2 O's next to each other. I'm going to cancel that out, and I'm just going to put in 1 O instead of 2. So that's the first edit that we have to this. And then the second one is that we want to change the last syllable of the name to IDE. And this is very important because that suffix IDE, the ending of IDE, tells us that we have a chemical compound that is not part of an element, it's not on the periodic table, these are atoms that have been bonded together. All right, so the way this one will take that gen, and so we'll be dropping that and replacing it with IDE. So the way that it looks like, in the end, it's dihydrogen monoxide. All right, monoxide. Let me get that together. So you might notice here that I also dropped the Y in it because once I add that IDE, I would have a situation where I have YI, and that again falls under rule number 3, the extra vowels. So that's why I would drop the Y and just stick with IDE at the end. So once again, that's dihydrogen monoxide. So those are all the basic rules that we have to follow for assigning names. So it's not going to get more complicated than this. It's all a matter of just having enough practice and being able to identify the covalent compounds and just being able to give them a name based on the elements that they are made of and how many atoms of each they have. So let's look at these short examples just to get a little bit more practice before I set you on your own. So this first one, CO. We know that it's one carbon and one oxygen. So if we wanted to give it a name, again, we just start with carbon and oxygen. We would say how many of each atom they have. So here we have one carbon and one oxygen. That's the prefix mono. So we get monocarbon, monooxygen. And then last thing we need to do is uh, drop that last syllable in our name and change it to IDE. So in this case, we get monocarbon, monooxide. But in this case, we actually bring up an exception that we still have to take care of, is that when we start the names in the first element we use, we don't use mono. Never start a chemical name with mono. So in this case, we'll be getting rid of just the first mono. We're still keeping the second mono because that's part of the second word. It's not the beginning anymore. And so the proper name for this CO compound is actually carbon monoxide. And again, it's very important to remember that we're only dropping the first mono, but not the second in this case. All right, so next up, we have the compound of P2F5. So these are phosphorus and fluorine. Again, fluorine, because it's the second element on this, will become from fluorine to fluoride, and we just need to say how many of each we have. So we get phosphorus, we have 2 in there, so we'll be doing diphosphorus. And then fluorine becomes fluoride, and we have 5 of them, becomes pentafluoride. All right, simple, straightforward. And this last one that we have is Mg and Br. So if you're following the same idea, again, we have magnesium and we have bromine. Again, magnesium comes first, and there's not more than one. So we'll be dropping that mono, just like in the monocarbon. So we'll just say magnesium. And then we get bromine. So bromine becomes bromide. We have 2 of them. So we say dibromide, right? Simple enough. Or you would think, because this actually turns out to be wrong, this is not the way we would name this compound. The reason for that is that it is not a covalent compound. If you remember, magnesium is a metal, bromine is a nonmetal. This makes it an ionic compound, and we actually use a different set of rules for naming ionic compounds. And we'll get to see that more in the next section, so stay tuned for that.